Hi, welcome to week 3. The goal in this week's lab was to measure the dynamics of material failure. Now, if you're part of the 99% of the population who doesn't know what that means, you're probably not the person marking this. But that's okay, because I don't really know what it means. So let's just whack it in Google Translate to find out. Huh. Looks like it's just breaking stuff. Specifically, looking at how things break in different ways under different circumstances. The group I was working with this week had a lot of good ideas for things to break. Styrofoam, tables, windows, our legs. In the end, we decided on rubber bands though. We chose rubber bands because we had a lot of them, and figured it would be easy to break them under several different conditions. First, obviously we needed a test case, so we hung them from a retort stand and dropped sets of 500-gram weights to see how much was needed to snap the band. We found that for a regular rubber band with no alterations, we needed 3 sets of weights, so 1.5 kilograms, to snap when dropping. Do note that for each test we used a new rubber band, to avoid having any already stressed bands changing our result. As you can see, the band stretches out and snaps at one point, releasing all the stored energy, usually in the form of flinging themselves partway across the room. Our first idea for braking under different conditions was a gradual increase in weight, rather than the shock force of dropping weights. We managed to hang up to 2 kilograms off the rubber band, but could not manage to have it snap in this case. While we were busy trying to measure the dynamics of our rubber bands failing, we inadvertently caused a different system to fail, as we put too much weight on the front of the retort stand. Our next idea was to vary the temperature of the rubber bands. First, we heated the rubber bands up by filling a container with hot water and submerging the bands for about a minute. What we found was that although they didn't appear to stretch any more or less, the total mass needed to break the band was now 1 kilogram instead of 1.5. Other than this, there seemed to be no difference in how they broke. Now, what sort of self-respecting scientists would we be if we didn't play with a little liquid nitrogen? We found 2 very distinct outcomes for rubber bands dunked in liquid nitrogen. One was to simply have a portion fracture off due to the impulse of the weight. The other, and far more interesting result, was that the rubber band would appear to stretch out in slow motion. When incredibly cold, the rubber becomes rigid, but as it warms up due to the atmosphere, it regains its elasticity. We managed to demonstrate several different circumstances where rubber bands would break, or not, in varying ways. That's all for this week, but I'll be back next time.